In this video, we're going to talk about structural formulas. Structural formulas are the progression from Lewis formulas. So if we had the Lewis formula for NH3, we know that nitrogen has 5 valence electrons and 3 times 1 for hydrogen for a total of 8 valence electrons. And so we draw our central atom bonded to hydrogen, bonded to a hydrogen, bonded to a hydrogen. That uses 6, and we get a lone pair here. That's a fairly straightforward Lewis diagram. It's really important to know that there is a lone pair of electrons here and that there are 3 bonds created. It's not unheard of to see somebody draw that formula like this with the Lewis diagrams, but this is starting to become a structural formula. Structural formulas, though, would not care about the lone pairs. They don't actually take those into account. A structural formula draws the bonds as a straight line. So this stands for 2 electrons forming the bond, 2 electrons forming the bond, 2 electrons forming the bond, and we disregard the bonding electrons. So if we looked at something like H2O, which again has 8 valence electrons, you have hydrogen bonded to your central oxygen, bonded to your central oxygen, and that's your Lewis diagram. Your structural diagram only shows that oxygen is bonded to the hydrogens with single bonds. So this is a single bond. If you had O2, where you've got 12 valence electrons, you have oxygen bonded to oxygen, you fill up the octet here, and that's 8, and that's 12. But then you have to move this pair here into here. You go O, and it gets a double bond between them. That's the Lewis diagram. Your structural diagram would just be this. It's just showing that we have a double bond between the oxygens. And so we show a single bond as a single line, double bond as 2 lines. And if we had N2, which has a total of 10 valence electrons, we get nitrogen bonded to a nitrogen. We fill up this octet and like this. And then we have to move 2 of these into the middle to make a triple bond. And we have the 2 valence electrons. The structural formula, though, would just be this. And so really all a structural formula is showing is what atoms are bonded to what atoms using a line as the bond, counting for 2 bonding electrons forming a bonding pair. And we can then show what's bonded to what with single or double bonds. So if I had CH2O, I've got my carbon is going to bond to a hydrogen, double bonds to an oxygen. And as you get more practiced in this, you'll see that each hydrogen has 1 bond, carbon gets 2 bonds, and oxygen has 2 bonding electrons, so it makes 2 bonds. And so it's going to allow us to draw some formulas that are more like this. We've got hydrogen, hydrogen, hydrogen to the carbon, oxygen, hydrogen. It disregards the fact that carbon has no lone pairs, but oxygen has 2 lone pairs. But we'll deal with that when we get to VSEPR formulas, which show the shape of the molecule. So structural formulas only show what bonds to what. It ignores the bonding pairs, and it doesn't really show us the shape yet. We'll see the shape of the molecule when we get to VSEPR or 3-dimensional geometry. We're not there quite yet. You need to do structural formulas before we can get to that stage.